So software testing, basically testing, normally what comes into our mind is the verification part of testing. However, testing is not only the verification part, but it is also to show that the program does what it is intended to do. So this kind of deals with the validation. So it discover program defects before it is put to use. To achieve this, you need to execute the program with artificial data. You check the results of test run for errors, anomalies, or information about programs. So why testing? Why we need to testing? Need to do testing because programs are made by humans. So normally humans are not error free. So whenever they work, there is a chance that they will do some kind of error. So software is never correct. No matter which developing technique is used, any software must be verified before using. So software testing and analysis are important to control the quality of the product, and these are often very expensive. And expensive normally it is in terms of time, because you cannot say that it is expensive in terms of cost, because normally the salary of the developer and tester mismatch. Developer salary are much more than the tester, so the number of hours, you can say, it takes to develop, like for example it takes to develop an application about 10 hours, so testing will take around 20 hours to test. So it is more expensive in terms of time rather than cost. So these are some of the examples that you need to know about software testing. Why software failed? Because there was not proper testing. So kindly go through these examples. So errors, basically these are part of our daily life. Human makes error in their thought, action, and in products which might result from their action. So there are two main things: fault and failure. If you have to categorize them or split them, fault is basically verification part, and for failure is basically the validation part. So fault is programming or design error whereby the delivered system does not conform to the specification and software does not deliver the service expected by the user. So failure is kind of validation and fault is kind of verification. So this is the flow chart. So error, there is an error, error becomes fault, fault becomes failure, then we have incident. So you can go through this chart to for better understanding of error, fault, and failure. So there are multiple terminologies that are being used. One is fault avoidance, fault detection, fault tolerance. Fault avoidance is basically to build the systems without having errors in the system. So these are mainly built or mainly used for mission critical systems or human lives, where human lives are at stake, where the mission is too important that even a small error can cause a human life. So that's why we use fault avoidance. So fault avoidance is obviously difficult to achieve and it requires a lot of testing. Fault detection is normally what we commonly do is testing and verification. Fault tolerance are those systems which can be built that continue to operate when problems, bugs, overload, bad data occur. So fault tolerance systems are easier to make, but they are not cheap. They are expensive because you have to buy backup or alternative. So that becomes more expensive. So what is the test case? Test case is basically you write something to check for the functionality. So in these are basically structuring test cases: test case ID, description, module, test data, test steps, expected result, actual result, result, or comments. So if you look at the test case template, so this is basically a use case template. For this use case, this is a simple use case for adding two numbers. So if you have to make a test case for that, so you have a test case ID, you have test item, wrote by, document date, test type, whether it is automated or manual, test suite number, product name, release, test case description, operation procedure, precondition, post condition, inputs, expected output, and you can also have one more here, actual output. So there is an input, expected output, actual output, and then result. So if expected and actual output are same, this becomes the test case becomes pass. So if expected outcome and actual outcome are different, so this becomes fail. So this is basically a test case where you check the functionality. So normally test cases are dependent on use cases, how many number of use cases you have. So you have to build that number of test cases as well. So testing strategy, there are two main testing strategies like we discussed: verification and validation. Verification, we check whether we are building the correct thing, And validation, we check whether it is traceable to customer requirements or not. So multiple types of strategies are there. We have code inspection, we have software testing, in which we have unit and functional testing, integration testing, system testing. Acceptance testing is basically done by the end user. So these all we have discussed uh, in the V model when we were discussing software process. So a new term that you may have heard is regression testing. Regression testing is basically when you make a new module, so you have to check all the previous and integrate with the previous system. So you have to check all the previous modules as well. So regression module or regression testing is basically expensive, because every time a new module is made, you have to test all the previous modules as well. So it is. We also have stress, security, load performance, and load testing as well. So if you see here, some of the tests are written in black and some are in blue. So the difference is these black tests indicate functional testing and these blue indicate non-functional testing. So there are three possible level of correctness. One is possible correctness. So you obtain correct output for some arbitrary input. For example, if you have made program for multiplication, so you give two numbers and you check whether the output is correct or not. You can only check 1, 2 or 3 pairs. So that is possible correctness. You cannot check all the things. Then we have probable correctness. Probable correctness is that you take the minimum value, minimum minus 1, minimum plus 1, you take the maximum value, maximum minus 1, and maximum plus 1. So you have tried different values which include 0, largest negative, smallest negative. So something like this which can contribute to probable correctness. Absolute correctness is can be demonstrated only by a test that involves testing every possible combination of the input. So if you are checking all the possible combination of input, so that is basically absolute correctness. So this is a testing example. Description is given, definition is given. So you have to make the test cases as well, and then you can check whether you have written all these, whether you have included these things in your test cases or not. So test cases, basically you can say test case design, the objective is to uncover errors. The criteria, it has to be done in a complete manner, constraint. We have to contribute minimum time and effort. A successful test that uncovers and as yet undiscovered error. So you are discovering an error which has not been discovered up till now. So minimum number of required tests with 100% functional coverage and 0% redundancy. So you have to check that the number of tests should be minimum, but they should cover 100% functionality and there shouldn't be any redundancy. Did a variety of test case design method. We have cause effect graphing, equivalence class partitioning, boundary analysis, vendor specific, you can say client server, object oriented test case design. Possible approaches: knowing the specified functions, tests can be conducted to demonstrate the each functionality is fully operational. Black box. So like we discussed in the class, that black box is something where you don't have to know about the box. You just give input and you check your output. If the input are matching to the outputs required, like the outputs are the output that you expect, so that means the function is correct. Knowing the internal working of the product, tests can be conducted to ensure all pairs match. So here you have to check internal coding as well. You have to understand or you have to know about the code as well. So this contributes to white box testing. So black box testing is where you don't look at the code, and white box testing is where you look at the code and you check all the details. You check all the functionalities as well of the code for the test.